This video is going to take a look at the Criterion C lab report rubric that the science teachers use to grade lab reports in the MYP, years 4 and 5, and it's also going to look at an exemplar lab report from for Criterion C that's quite strong. We won't get into specifics about what scores it would earn, but I'll try to point out places where it's done things really well, and also places where maybe it could be a bit stronger. So when you get a grade back on a Criterion C lab report, it's going to be based on 4 different strands, which I'll go through on the following pages. But what you earn in each strand, whether you end up in the 1, 2, 3, 4, 5, 6, or 7, 8 category, is based on the following. To earn a 7, 8, which is the highest, the objectives have been completed accurately with an extensive level of detail and only very minor errors. The difference from 7, 8 down to 5, 6 is that the objectives have been completed but are lacking in some minor ways in terms of accuracy, detail, omissions, and or errors. So 7, 8 means, not a perfect lab by any means, but it means that you've completed everything that the criteria say you have to complete. You've used a thorough level of detail, and any errors that you have made are really quite minor and don't really take away from the overall quality of the lab. The difference with the 5, 6 is that you've still met all the objectives, but you're probably making more consistent errors throughout, or maybe leaving some detail out throughout the lab report. So it's sort of the level or the consistency of errors, the consistency of leaving important details out, but you've still generally met all of the objectives. For level 3, 4, we're now looking at more major errors. So you've tried to hit all of the objectives of the criteria that we're going to look at, but in at least one major way, there's some key criteria that you're not hitting, or that you're hitting with rather big errors that really take away from the overall quality of the report. And to get 1, 2, it means that multiple significant omissions or errors have been made in trying to address the objectives that I'll talk about on the next page. So the first objective that we have for the criteria, the strand 1 as we call it, is presenting the recorded data in tables and graphs. So that means we need to have our raw data. Raw data is data that you have not done any calculations on, any processing on, any graphing on. So this is the exact data that you collected yourself in the lab. So raw data has been collected and organized logically into a data table with accurate labels and units. So if we look down below, here is the raw data table from this exemplar lab. This is for a lab using the Dynoscope to measure the area of red onion cells as they were put under different concentrations of a sugar solution to see how the concentration of the sugar solution affected the area of the red onion cells. It has to do with the concept of osmosis. So this is the data table, concentration listed here. This is the independent variable. Cell wall areas 1, 1, 2, 2, 3, and oh yeah, so here now I see what's happening. Cell wall area versus cytoplasm area. So that was both important measurements. The cell wall being the outside of the cell, and the cytoplasm being inside the cell. And so what the student's going to look at is the difference between the outer cell wall and the inner cytoplasm on the inside. So the student measured the area of both of those things. Now, there have been some mistakes in this student's table. It's not perfect. It is generally a well-labeled table. However, there are some errors with units. So right here, it's listed as UM. Now, this was meant to be the micrometer sign, not a U. So that's one mistake. And the second mistake is that this student was measuring area, and so micrometers should have been written as micrometers squared, because that's the proper unit for area. And what the student did instead is that they listed the number as being the number squared. So that's actually a rather big error to make when you're presenting your data. To have the wrong unit and to have your number squared is really quite inaccurate. So in terms of the raw data, certainly could be a bit better if we want to reach that 7, 8 level. We want to make sure that we don't have any mistakes with our units. Data processing has been carried out correctly, and one sample calculation has been presented clearly. So The process data is explained. The equation that was used in this lab was to calculate the percentage difference between the cell wall area and the cytoplasm area. And while the equation is presented, there is no sample calculation. So a sample calculation would mean that after you present the equation, you actually plug in the values from one of your trials. So this student could have picked any of these trials from up here, like this one, and shown how they used the cell wall area and the cytoplasm area in this equation to get a percent difference value. So without that, again, this student is not really reaching the 7-8 level. It's still a very clear presentation of the final processed values of percentage difference, but without that sample calculation, it can't get to level 7-8. Okay? And then the third part of strand C1, so we just did all process data has been organized logically into a data table with accurate labels and units. And now most graphs or most labs will involve a graph of dependent variable on the y-axis and independent variable on the x-axis. It should be presented in an appropriate format and style for the lab. In most cases, that's going to be a scatter graph with a trend line. Some cases, if it's been specified, it may be a bar graph with error bars. So you're going to have to pay attention to the instructions of your teacher to make sure that you're using the appropriate style of graph. No matter what, the graph needs to have an accurate title that's very descriptive. It needs to label the different axes and have units on the axes when that's appropriate. So here, this is the student's graph. The graph has been explained. Really, I don't think this explanation is necessary. I would rather have just a very informative title that speaks for itself. So this graph says concentration of sucrose affecting cytoplasm area within onion cells. That's mostly true, although technically what we're seeing here is concentration of sucrose versus percentage difference. And so that percentage difference should probably end up in the title of the lab. The student has these data points and has tried to fit a trend line to it, although it's not a very good fit. And so the student might want to consider playing around with the data as different series, only adding a trend line to these data points that seem to fit more of a linear trend, and these data points, leaving those off, which don't really seem to fit it. If you're going to have a trend line, you should include the equation. There's a way to show the equation, either if you're using Google Sheets or if you're using Excel. And I would always encourage you to include the equation and the R² value so that you can talk about how well your data matches the trend line. So that's strand one, raw data, data processing, and graphing, showing them clearly, presenting them in tables, having the proper label and units, and showing sample calculations. Strand 2 is interpreting the data using scientific reasoning. So the objectives are the data results are accurately interpreted using appropriate terminology such as linear, proportional, etc. The data results are compared in detail to the hypothesis, which you restate, and to accepted scientific understanding. And the scientific understanding is explained using correct scientific reasoning. So in this lab, the person is going to discuss the relationship, and she talks about the relationship that I have seen between the two variables is that as the sucrose concentration increases, the percentage difference also increases. So we've clearly stated the type of relationship. This is demonstrated when one can see that for the first two concentrations, there's no difference in the areas. However, as the sucrose concentration rose to 0.4 molar and above, there was a clear percent difference between two variables. And this kept growing as the solute became more concentrated. Now, I think it does eventually go on is a linear relationship. So again, the type of relationship has been stated. Perhaps it could be more concise, but the student is getting across that they can see the relationship between them. Now, I don't think it's perfect. It does talk about how the data points match the trend line very closely. But when I look at this data, to me, this doesn't scream very closely. Very closely would be if the points are right on the line on either side of the line. And there's a lot of points that are sort of outliers in this data. So your data doesn't have to lie really close to the trend line. It's okay if it doesn't. Your data is what it is, please make sure that you try to discuss your data honestly and accurately. And if it's close to the trend line, great, you can say that. If it's not, then say that there are many points that fall off of the trend line. The student has mentioned the R-squared value, which can be referred to as the correlation constant. A value of 1 for R-squared would imply that the data perfectly matches the trend line. And so the lower the value, that means that your data less closely matches the trend line. So 0.94 is a reasonably strong relationship between the two, although not perfect. The student has also then compared what has happened to the hypothesis. And so if one increases the concentration of solute, the percent difference between the cell wall area and the cytoplasm area will also increase. And then goes on to say that the higher the concentration of solute results in more water being drawn out of the cytoplasm, causing the cytoplasm to shrink and shrivel. So this is getting back into the scientific concepts. Note the hypothesis has not been restated, and it should probably be restated right at the start of this section. But the student has discussed the scientific concepts again, and then down here, this is very good. And particularly that the student actually tried to explain why those two data points here don't really fit the rest of the trend. Why do they have 0% change when the rest have quite a bit of percentage change? And so that was probably the reason why this earned rather high marks, is that it didn't just go to try to explain the general trend. It also tried to explain some of the more outlier type data points using the scientific theory behind osmosis. So that was very strong. Strand 3 discussed the strengths and weaknesses of the experimental design. You're going to look at the reliability of data discussed with correct and specific reference to is the data accurate or is the data precise? Precise meaning, are the data points consistently close together when you're repeating trials, or are they really all over the place? And accuracy is how closely are they matching what they should match, the true values, the expected values. The strengths and weaknesses of the method are described in detail, clearly and logically explaining their impacts on the reliability of the data, and limitations in the amount of data collected, if relevant, is described in detail to explain its impact on your ability to interpret data. So I'll try to explain what all of those mean with these examples. So in terms of reliability, the student was going to look at how closely do the percent difference values, how precise are they? How close to one another are they? And so like in these first two trials, there's 0 every time. But you can see in some trials, especially this trial, the percentage difference values actually vary quite a bit. We've got one about 40%, one about 46%, one about 26%. That's a lot of variation when really we would expect them to be quite close together. Then we've got this last trial for 1 molar where they all stay pretty close in the low 50s. So that's what you'd be discussing in terms of reliability. The student says the data that I collected was quite reliable. There was some variation between the 3 trials, and I think that the student could really point this out, that be more specific, that it was really that 0.6 molar trial that seemed to have the largest amount of variation. The biggest lack in precision was in that trial, but that in most of the other trials, the percent difference values were quite close together. The student also says that there are no major outliers and that the points all lie very close to the trend line. As we already discussed, I don't really agree with that, and I think the lab would be stronger if the student more honestly assessed how close the values were to the trend line. In terms of strengths and weaknesses of the method, the student's done a very thorough job actually discussing very specific strengths in the method, and you can pause the video and you can read through the specific things that the student has written. They've also looked at weaknesses, which is probably a bit more important. The student has identified the variation in time in her method as probably one area that caused a lack of precision, that caused variation between her trials. And the person has also looked at the amount of solution that they added. So due to the amount of sucrose solution added and how that varied and how that probably had an impact as well. So when you're looking at weaknesses, you're really often going to look at your control variables. Usually you're going to look at, did I truly control things, all these other important factors, as closely as I could, or were there things that I assumed were controlled and maybe they weren't, or were there things I know I didn't control all that well? Because that variation and that lack of control is often what leads to a lack of precision, sort of inconsistent data points. So those are all important things. The student did a nice job of considering the control variables that lacked true consistency and explained how that may have affected the results. The student also did a good job looking at the limitations in the amount of data collected, mainly that only 3 cells were used for each concentration value, and also that only 6 different concentrations were used, and they were about 0.2 molar apart in their concentration, which was kind of a big gap. And so there were big differences from one trial to the next in the amount of percentage difference. So that meant that just the data ends up being a bit choppier and a bit, the trend line doesn't match it that well. And so what the student is saying is that more repeated trials for each concentration would have helped improve reliability, but also testing the concentrations in between these concentrations that they tested, that would really help fill out the overall data. So it's really good that the student brought those up. They could possibly explain the impact of having that little data a little bit more, but I think they've done that to a reasonably good extent. And so Strand 4 is improvements. Essentially, anything that was brought up in Strand 3 should now be addressed in Strand 4 with some simple ideas for how things could be improved next time. So realistic improvements suggested that directly link to all highlighted weaknesses. So anything that you brought up as a weakness or a limitation should now get addressed. The improvements described are described with enough specific detail to be carried out exactly. So don't just say, next time, do that thing better. That's not going to cut it. You need to tell me, do I need to use a different piece of equipment? Do I need to use a specific new concentration, a specific new number of trials, things like that. Improvements need to address both methodological issues, so actual like procedural steps, as in how you did something or what equipment you used, but also limitations in the amount of data. So those weaknesses that were brought up before should be addressed with referred to how many trials you did or how many independent variable values you tested. And the impact of these proposed improvements is logically and accurately explained. This is one that people often miss. They often suggest improvements, but don't really get into why that improvement would help or how that's going to help the data. So try not to skip over that because it will prevent you from reaching the highest levels of achievement. So note that in the last section, the person talked about the variation in time and the amount of solution having an impact. And so now the person has directly improved that by saying they're going to give themselves more time from 3 minutes to 4 minutes, which will ensure they have a bit more time to take the picture and do it consistently for every trial. They also specify an exact amount of solution that they're going to add, which fixes another one of the methodological weaknesses described in the previous section. And then they have a section on how to improve the amount of collected data. Instead of 3 cells, the students said they will take pictures of 6 cells. And then they said instead of going from 0 to 1 molar concentration, they're going to go from 0 to 1.6. And they're going to test every concentration every 0.1 molarity. Now, that is a lot more data than they suggested previously. And so they might want to, they do comment about how they had 30 minutes of extra class time. And so that's why they think they can get all of this data done. But they might want to suggest that this is a lot of new trials that they're going to make themselves try to take. So it would be pushing it to go from 0 to 1.6. But overall, they have addressed both the limitations in data that they suggested here, not enough cells and not enough concentrations that are too far apart. And so I think their improvements are very good to address the weaknesses that they brought up. Perhaps they could have talked about the impact of these improvements, mainly that they'd be more confident in their percentage differences because they'd have 6 values. So any outliers would hopefully, their impact would be minimized when averages are taken. And by having more data points for the independent variable, they'd perhaps see a more clear trend between their independent and dependent variables. and their data would hopefully more closely match the trend line, and they could tell if it was really linear or if it was more of a curve. So those are the 4 strands of the Criterion C criteria: presenting recorded and processed data with graphs, interpreting that data with scientific reasoning, assessing strengths and weaknesses in the design, and suggesting improvements. And the level of achievement is determined by how complete your writing is, how much detail you use, how accurate it is, and whether or not you are making a lot of errors.